Hello, everyone, and welcome to episode 52 of Nutanix Weekly. I'm your host, Andy Whiteside. I've got Harvey Green and Jirah Cox. Hey, guys, how's it going?
Howdy.
Pretty well.
Is it me or is it a little slower these days in terms of content coming out? Not just for Nutanix, but for a lot of our vendors. Are we in that time of the year where we're getting ready to go into summer and people are starting to plan their vacations? Is that what's going on?
I'd say it's either that or they're kind of like me right now and so busy that you gotta just figure it out.
Could be doing both. Could be very, very busy figuring out where summer vacation is this summer.
Also true.
Well, it could be that we're really busy, trying to work. Right? We're working, heads down, solving real problems. It could be that vacation stuff's kicking in. It could be that we've solved all the world's problems and now we just need to coast the rest of the way.
Sounds good. whatever you say, Andy.
No buy-in on that one. Well, you guys, I'm looking to retire. No, I'm just kidding.
Somehow I thought solving all the world's problems would feel different, I guess. But there I go, having expectations again.
Well, let's start by solving this one. This one came off the Nutanix community blog forum, and it's running stateful applications with Red Hat OpenShift on Nutanix HCI. All right, Harvey, define what the word stateful means in a technology world.
So stateful in Harvey's view would mean that the state of that machine will move from one place to the other across reboots. So sort of like persistent that we use in the EUC world.
All right, Jirah, what's stateful mean? Because stateful packet inspections, first time I ever heard that word. What does that mean?
Yeah, I would agree with Harvey, right? It means like what the app does gets written somewhere. Like persistent is a great word there, right? Like when you stop it and start it again, what it did is preserved. It doesn't just wake up empty, no record of like transactions.
And that's important?
Could it be? I mean, depends if you work at my bank, it could be very important.
Well, unless you're spending and you want to go back to what you had the day before.
I don't know. I think, Jirah, it'd be very useful if my bank account started with $1 million in it every day. And no matter what I did the next day, it'd just be at $1 million again. That would work.
That would definitely not be very state preserving, would it?
Well, I think that's kind of a good point. I mean, in some cases, stateful is good and you want it that way. In some cases, stateful is bad and you don't want it that way and you don't want it.
Well,
what's an example where you'd want it
to start with 0 every day? That would suck.
Every day you can spend only what you're allowed to overdraw. And then, yeah, that pin to a certain number value, it actually matters what that number is.
I'd be at the bank at 9:01 out drawing out everything I could.
Yeah.
And back there the next morning. I'd be the Bill Murray of Bank of America. Groundhog's Day.
Yes, I got it.
All right. So what's an example of when you would want, well, first of all, let me give an example when you wouldn't want stateful, and that would be like non-persistent VDI, right? Whatever that junk is you put in your virtual desktop that you don't want to be there for various reasons. I can tell you a while ago, I fell for there's a puppy dog lost outside email, and I clicked on it for whatever reason. And I got this big ugly website I hope came from my own team saying, we got you. You shouldn't have been doing that. Anyway, I don't know. I closed it so fast. I don't know exactly what it said. It said something like I've been owned or something.
Yeah, that sounds about right.
But in this case, stateful in the world of Nutanix and specifically in the world of Linux and more specifically in the world of Red Hat OpenShift, what's that mean? Jirah, answer that question and then also include what is Red Hat OpenShift? It's been a while since we talked about it.
Yeah. So in order, right, like an app that could need statefulness could be like, in this case, and we'll talk about this example, like a database, right? If I want to run a database, for any use case other than managing Andy's bank account, then I'd want it to like record transactions and like, save the data that I write to it. Probably applies to just about any application we run in the data center, right? If we give it storage and people would scream if that storage was not there, that application has some state to it. And that, only a small handful of things wouldn't fall in that, right? Like if I had a load balancer maybe that You know, I can send an API call to it to say, hey, add a new backend leg to the load balancer, and then maybe it goes away and it's very transient. That app has not a lot of state to it, right? When it boots up again, if it came up with nothing, I would re-inject all those same kind of routes and bring it back to life. But for the most part, just about everything would have state to it. OpenShift, right, is Red Hat's platform for running containerized applications on their frameworks, of course, on Nutanix HCI as well. So a very valued partner of ours and a great way to run OpenShift. So if you're looking for an easy way to launch a containerized infrastructure very easily, right, and very consistently, and actually have, you know, I think of it kind of as like a opinionated way to run containers, so that kind of like if you're thinking about like a factory, you could of course install any number of container frameworks and give yourself an empty factory, bare floors. You get to do everything from the ground up. Whereas I think of OpenShift as more like a very opinionated, like this is where the conveyor belt already is, tooling's already here. Bring in your raw materials and just start cranking out the widgets that you want to make, right? So there's a lot more things that are available to you and already pre-plumbed on day one when you open up business.
Harvey, where does that fit in the world of Kubernetes and needing to run that stateful workloads?
Well, I mean, the biggest piece is the one that we kind of already hit on a few times around whether or not you need data to remain each day or each time that application is started again. You know, if you don't, if every day or every time that application is run, it's working a job to completion, and you just want it to do a new job to work to completion again, then you don't necessarily need something stateful. But if you have, something that needs to keep a certain set of information every day, or start with where it left off the last time it was running, then you definitely would want something stateful that's keeping up to that, or keeping up with that, I should say.
Well, and so, I mean, you touched on Kubernetes there, Andy, and the article opens with a great discussion about, polling the Kubernetes community, right? And recent respondents saying, 90% of them saying absolutely ready for running stateful workloads. And then a good chunk of them, 70%, are already running it in production, right? So then it comes down to, let's walk through kind of an over your lunch break lab exercise around how to actually get that up and running, in a demonstrable fashion.
So is this asking what percentage of Kubernetes users are able to do stateful versus the ones that can't?
This survey, which it actually links to, right, talks about community perception of his Kubernetes ready to run production workloads with stateful applications, right? And that's the overwhelming 90% there, is a yes. And then most of those people saying yes already are doing it as well.
Mm-hmm. So I guess I don't live in that world. So I really don't know where, containerized workloads have had statefulness and where they haven't. I guess, was there a big percentage of time where it wasn't available as a persistent workload, a stateful workload?
So by default, when you launch a container running an application, right, the container itself is not changing. I'm not sure if it's 100% immutable intrinsically, but it doesn't change. You're not saving data into the container. You have to give it external storage, right, where it can, keep notes to itself, write configurations, even write, actual contents, like a database container would write the actual database tables and payloads and so forth.
Yeah.
So until you're providing that containerized storage for your containers probably aren't saving much. No, they can connect to other databases, they can connect to backend systems, pull down configuration data to provision themselves, but by itself, there's not a provision for that kind of storage.
And that's kind of by design, right? That's how Kubernetes was built. The idea of a container where it had its database and it was the application workload, and it would get what it needed for like a config, and it would run, but then it would write its data to the database, and then it would just go away or reset back to its original state when it was turned off and back on.
Totally, yeah. So like in the parlance or in like the framework of, let's say enterprise IT 20 years ago, right, where I had to build a server to run an application. The application came with an installer, right? Next, finish. And I brought the storage in the form of whatever I gave that server, physical or virtualized. And then, of course, that app packaging, right? That MSI file had to unpack the application workload and then tailor it for that environment it was going to run in. And containerization says, let's get rid of all of that, right? I don't need to unpack it. I don't need to tailor it. I can literally just take it from a file I download from the web to it is running pretty much instantly, right? Within configurable networking, configurable storage, but the application itself doesn't have to get modified to then be able to instantiate.
Yeah, I'm kind of seeing this like, I move into an apartment or a condominium or a house and I got to unpack and get all my stuff there. And my stuff's there. And all that goes along with the baggage of my stuff being there is there. Versus the Kubernetes where it's coming in and I leave the next day and somebody cleans it back to the original state. In this case, I can leave a little me behind. So when I come back, I'm not starting over.
Yeah, in some ways, right? I mean, your Groundhog Day analogy from before is a bit apt. Yeah.
And what's an example of things I would leave behind? Configuration type of information?
Yeah, for sure. Right. Like I run a containerized load balancer here at my house that it writes notes to itself about, what backend sites do I want to proxy or load balance and how to access them and what ports and health monitors, right? So the actual code that runs the load balancer doesn't change when I start or stop the container. But when it does start up, it or after a container update, it finds that configuration file on the storage I presented to it, and it will reconfigure itself.
And what's the magical piece of Nutanix hyperconverged that makes that happen?
So in this case, and what this article illustrates, right, is actually that the CSI driver, right, the container storage driver that lets the containerized framework, in this case like OpenShift, know how to request storage resources from the Nutanix cluster that I'm running on, right? In this case, it'll use like a Nutanix volumes, so like a block storage presentation. It could also be, files over SMB or NFS. But for this example, it's going to be block storage via volumes to say, here's storage just for that one application.
Okay. Harvey, any comments?
Not yet. As you kind of talked about, this is a little outside of my box, so I'm gonna let Mr. Jirah keep going, and I'll jump in.
Well, that's the question. I mean, I think we've introduced the concept and the reason why. I don't know that we want to go through how to do it necessarily, Jirah, right? That wouldn't be good listening for our audience. Is there?
We definitely should summarize like the actual bits of code for sure. Yeah. It's the technical Nutanix blog for sure.
Yeah. Well, you want to walk through the different pieces here?
Yeah, to whatever the verbal spoken equivalent of like pseudocode would be from our, CS 101 programming classes. In this case, this article is actually the fourth of a 4-part series talking about deploying OpenShift on Nutanix. So it assumes you at this point have a Nutanix environment running OpenShift with the CSI driver already injected. And if you're not up to that level, right, the previous blog post will get you there. Once you have all that, right, the article talks about installing Git, installing the OpenShift CLI, and then Helm, which is like a multi-package manager, right? It's a way to install applications onto the Kubernetes framework. And then verify the CSI operator storage. So does my OpenShift environment know how to talk to Nutanix, know how to authenticate, and then actually be able to request new storage provisioning? That let's assume that you get a yes out of all of that, the way the blog author does as well. If not, go back and try again or troubleshoot. And then install Postgres, right? So some Helm commands here for how do I install Postgres, right? A database engine onto my Kubernetes, aka OpenShift environment. So install Postgres, verify that it's up and running. That'll be listed there in your running pods. And then there's a command here for getting the PVC, which is the persistent volume claim, which is what storage have I requested for this application? And there's a reference there. And then the blog post also gives you a couple of scripts to run, scripts to, let's see, I lost my place here. So Oh yeah, so we create some data, right? So create some new tables within Postgres. So we're creating persistent data that we need to have that application state, right? That needs to remain even after terrible things happen to the application. How do I make sure that that data sticks around and is useful? And then another script that will snapshot that database volume every 5 minutes. So we've created data, and then after a couple of minutes, we'll have a few snapshots over time, right? So how would I do data protection in a containerized application world?
Okay.
And then some more commands here given in the blog post article. Yeah, okay, to run, yeah, right, to validate the script, the tables, to create the scripts, run them. Yeah, okay, and then verify that all scripts are running in the background. So then we connect to the Postgres database, and it gives the sample credentials here. Don't use these credentials in production, please, and thank you. But for a lab environment, you can use these credentials. And you should see that those tables exist, right, that we created as proof of like able to create data that should persist. So then we see our data, everything's healthy. And then also over time, right, we should see that there's, the article calls out 5 volume snapshots that have been created, right? So every 5 minutes is going to snap that application volume. So now we have our database running. It's got data in it. Even think in a regular old school fashion, right? Take the containers out of it. We have a database running. There's data within that database, and we have some data protection snapshots of that data. Now we're doing it in a very fancy, web scale modern way of doing it with a containerized database and CSI driver storage for containerized apps. But fundamentally, right, we have a database with data in it. So now we need our chaos monkey, right? We're going to cause the failure and then prove that we can recover from it, and that we've preserved that application state as we do that, right?
Well, maybe that's the key for me is this is starting to make sense in terms of now, if that container something were to happen to it, we would have what we need to bring it right back up, or is it right, make it available again instantly?
Yeah, right. What, depending on your availability model, availability zones, but something bad happens, how do I reinstantiate that application, right?
Mm-hmm. Okay.
Whether that's a recovery in the next cabinet over, the next row over, next data center, depending on how far you've replicated the data. But also, and I think we'll get to this later on in the blog post, we have snapshots over time as well, right? And it's a database. I mean, I know that none of us know a database that's ever had like an error caused by like actual human error within it. But if such a thing were to ever happen, the ability to go back in time, like 5 minutes to before the error happened, that seems like it could be useful in certain circumstances, right? Mm-hmm. So for this example, this walkthrough, the chaos monkey is going to be, we as the human are simply going to uninstall Postgres, so no more database engine, right? That entire pod goes away from Kubernetes, and then delete that volume claim, right? So there goes the storage for that application. So then to restore it, right, from the latest available snapshot, there's a command here given to create a new volume claim, a new persistent volume claim, PVC, from the most recent snapshot. And I won't read the code to you here, but you should look that up and use that. Once the claim is online, now we'll reinstall a fresh copy of Postgres, basically from the internet, right? Like if I had a brand new Kubernetes environment that had no cached pods and no images in my container repository, I could still fetch this, latest Postgres image, fire it up, connect it to that storage layer, and then the next command is we're logging into Postgres and we're seeing what data exists in these tables within the database. Mm-hmm. And of course, we should see what we expect there. And then the last example given here, right, is what if we wanted to roll back to an earlier snapshot, an earlier state, right, of that database? We could actually create a new volume claim pointing to an earlier snapshot, and we'd be able to compare those over time and say, here's the earlier data, the older data, the newer data. Those can be different and get both accessed at the exact same time. So then I could even deploy, a second copy of Postgres, one to point to the first snapshot, while one's pointing to the last snapshot, all at the exact same time. So
I think you've blown Harvey's mind.
I am learning.
I'm sorry, and/or thank you. Whatever kind of Monday you're having, Harvey. There you go.
Both.
That's kind of the state that I usually live into. But because this is a key capability, right? Why does this matter? It's because enterprises are wanting to build and run containerized apps, even if it's like in this case Postgres, right? Companies run Postgres all day, every day. That could have been in a virtual machine, and then tomorrow that can be in a container, right? Same Postgres, same outcome for the business if it's a database. So I need to make sure that we maintain the same capabilities around data protection, recoverability that we had in the old world, where it would be a database in a VM. Tomorrow it's a database in a container, but same capabilities, right? Of roll back, roll forward, protect data, recover data, keep the business running.
Is this really just an example of your enterprise Linux workloads and that meshing up with Nutanix hyperconverge and all the beauty that goes along with that, kind of all those things meeting, and all of a sudden things become possible that weren't possible before?
I think that's a cool way to think about it. Yeah, for sure. I think there are some elements to that with Linux. I mean, containers on Windows are a thing as well. And then really what I think the Nutanix part of the magic we bring here, right, is that ability to sort of easily provide, actually, you think just like we did, 12 years ago with the birth of HCI, I create VMs and they also have storage and it's nice and simple. Well, now I have containers and they also have storage and it's all nice and simple.
Yeah. And this is taking containers to a world where it wasn't before, and the applications, the applicability of it becomes extended.
Well, and I think, with enterprise data protection, right, like snapshotting and rollback, roll forward, combined with also not having to reinvent any wheels, right? Like you could buy a Nutanix cluster. We've all talked about the foundation process here. That thing comes to life, the morning it hits the loading dock if you want it to, right? If you've got your VLANs set up on the switches, that cluster is online real fast. Mm-hmm. Now it can be running OpenShift the exact same day. Oh, and by the way, it can be running OpenShift with enterprise-grade storage that afternoon, and you're running applications in production by close of business, right? So very, very dramatically short time to value compared to lots of other ways you could do this, right? To like write your own application storage level, but you'd be almost, building toys for your toys at that point, right? Versus like I just turn on enterprise-grade features.
Yeah. Yeah, I get it. I mean, it's not necessarily my wheelhouse, but I get why it would be applicable if it was.
Cool. I think it's very exciting stuff. I also this is the kind of stuff that I usually tend to save for my like lab hours, late at night versus things that I'm fully proficient in myself. But we're all getting there together.
Yeah.
Right.
Well, Harvey, any additional thoughts or comments on this?
No, I mean, I guess the thing that I would say that, I mean, it's funny. I think I continue to say this on the podcast. The more that we do and the more that we highlight, it just highlights to me how flexible this Nutanix solution really is. You can have, something like this being able to run the stateful applications that are Linux based and have that be your entire workload and not touch a whole separate thing that Nutanix can do. And then, the same for databases, the same for EUC, the same for just random file servers. Like this is a hugely flexible system. It's hard to find holes.
You could picture a company that would like buy Nutanix for its, EUC needs, buy Nutanix for its application developers, and the developers go, oh wait, it can run desktops too, and the EUC guys would go, wait, what are containers, right? And it's like they run the exact same platform.
Yeah, that's key. I mean, that's really cool, and it solves a lot of business challenges. And maybe there are different clusters, and maybe in some organizations, just all one big cluster. It doesn't matter.
Totally.
Yeah. Hey, Jirah, I wanted to ask you about the syntax of this one right here. No, I'm just kidding.
I'm down, man. Let's go.
Well, I was looking through there trying to find one that I totally didn't understand. And to be honest, there wasn't one.
Can I Google faster than Andy can ask the question? Maybe. We'll find out.
All right, guys. Well, I appreciate you jumping on and talking about containers and OpenShift and the ability to do stateful workloads in a Nutanix world.
Cool.
Absolutely.
Appreciate y'all. Talk to y'all next week.
Have a good week.